Hi again, everyone. So we've got a second short video. There's a couple of things to consider when we use measurements that we have taken, and then we consider the error in those, and so how we then build on that. So I've got two examples, one from the book, the other one just taking the questions but changing the numbers basically, and having a look at how we might consider these things in the cases of perimeter, which of course is a measurement, and area. Because perimeter, you're adding measurements, and so as you add the measurements, each measurement has, in a sense, compounds the error, because each measurement has an error. So your final measurement of the perimeter, what's the error in that, is basically the question we're asking. So let's have a look. The length and breadth of a rectangle were measured to be 9 centimeters and 5 centimeters respectively. All right, so we've got a rectangle here, not particularly to scale, but we've got that, and we're saying, okay, so we're going to go 9, and we're going to go 5. And so, as we look at that, we say, oh, let's calculate the perimeter first. All right, so P for perimeter, I'm going to do that. P is equal to, well, there's two sides of 5, they're equal. Two sides of 9, they're also equal. And so we've got 5 plus 9 plus 9, which is equal to 18 plus 10 is 28 centimeters. Well, we should all be happy with that. Now, the thing is, we need to find the upper and lower bounds of the rectangle's true length and breadth. All right, so for the measurements, and I've got 5 centimeters here, and then I'm going to move down a bit and say 9 centimeters. Both of these are measured, as far as I can tell, it's not to one decimal place. Both of these are measured to the nearest centimeter. So the precision, as we saw earlier, precision is equal to 1 centimeter. That's for both, actually. And so the absolute error for both is equal to plus or minus half times 1 centimeter, which is equal to plus or minus 0.5 centimeters. Now this takes me that, therefore 5 centimeters is going to be 5, actually plus or minus 0.5. So it's between 3, no, why did I say 3? It's 4.5 to 5.5 centimeters. That's the lower bound. I'm going to do red as lower bound and blue as upper bound. For my 9 centimeters, it's the same. It's going to be 9 plus or minus 0.5, which is equal to 8.5 when we take it away to 9.5 centimeters. So that's my lower bound and that's my upper bound. Right, so there we have it. Those are the, in a sense, the ranges of measurements it could be. The 5 centimeters could be anywhere from 4.5 centimeters to 5.5. And the 9 centimeters could be anywhere from 8.5 centimeters to 9.5 centimeters. So the next question then asks us, hence find the lower and upper bounds of the rectangle's true perimeter. Find the upper and lower bounds of the rectangle's true perimeter. So in a sense, what we're saying is, well, there's a lowest value that the perimeter could be, and there's a highest value. So I need to add some space. So I'm going to do that. Excuse me a second. No, need to insert space here. So what we're saying is this part C, the smallest possible perimeter is equal to, well, I would take, if all my measurements, the error is maximum to the lowest rate, then my perimeter, the smallest possible perimeter, is 4.5 plus 4.5 plus 9.5 plus, oh, my apologies, 4.5 plus 4.5 plus 8.5 which is the smallest of the range for my 9 centimeters, plus 8.5. That gives me 17 plus 9 is 26 centimeters. So the error, well, that's the lower bound. We could also call it the lower bound, is 26 centimeters. The largest possible perimeter is equal to 5.5 plus 5.5 plus 9.5 plus 9.5. Gives me 19 plus 9, which is 30 centimeters. So that is, in a sense, the upper bound for my perimeter. Taking into account if all my measurements are at their maximum error on the upper end, then it would be 30 centimeters. So this is my lowest the perimeter could be, and this is my highest. So the question D says, what is the maximum error of my original measurement? So my perimeter is equal to 28 centimeters. That's my measured amount. So the error, there's two things I can measure. 30 minus 28 is equal to 2 centimeters. 28, which is the measurement I took, minus the lowest the perimeter could be, 26, is 2 centimeters. So my maximum error is plus or minus 2 centimeters in this case. All right? So that's for perimeter, where we're adding. Anything to do with adding lengths together, we get that. Let's have a look at one which is area. Which is this one. A rectangle has dimensions measured to be 12 meters by 15 meters. So I'm going to draw this over here, something like that. We've got 15 meters and we've got 12 meters. Now, instead of perimeter, which you do the same thing, we are going to do area. So part A says calculate the area. Well, that's simple enough. Area is 15 times 12, which is 12, which is 6 times 30, which is going to be 180 square meters. 180 square meters. All right? So we want to find the lower and upper bounds of the true length. Now, by this stage, hopefully, you can see why. I'm just going to write them. If you have questions, you can check with me. But the limit of accuracy or the precision is 1 meter. They're both measured to the nearest meter, which means the absolute error is 0.5. So I would say that the measurements are going to be between 11.5 meters to 12.5 meters. That's for the 12 meters. And 14.5 meters to 15.5 meters. Again, if you have questions as to that, you can look at the previous work and think, how did I get that? I look at the smallest unit it can measure, which is 1 meter, halve that for the error, and then I add and subtract it. So the question is, if I have these possible values, 11.5 to 12.5 and 14.5 to 15.5, what is the largest possible area and what's the smallest possible area? So smallest area, which we call the lower bound, is if both dimensions are the smallest they can be, which is 11.5 times 14.5. And so if I work that out on my calculator, it's going to be 11.5 times 14.5, which is equal to 166.75 square meters. Now the largest it could be, largest area, according to the error, which is the upper bound, if both my dimensions happen to be so much error that they go to the maximum amount, which would become 12.5, which is my upper bound of the 12, times the upper bound of the 15, then that will be 12.5 times 15.5, which is equal to 193.75. Now, this actually, it's going to have two error amounts. It's not symmetrical in this case. So we want to find the maximum error. Maximum error for the area. So here we do it. So the first one is going to be 180, which is the measurement I took, was 180, right? This one is the one that I measured. 15 was what I estimated, 12 was what I measured, and multiplied together, you get 180. So I get 180. Let's subtract the 166.75. That's my lower bound. So 180 minus 166.75 is equal to 13.25. Okay? Square meters. That's the error from the minimum. What about from the maximum possible area? 193.75 minus 180. What's the difference? And that is 13.75 square meters. Let's just double check that. 13.75 square meters. So the maximum error is actually this. The maximum possible error is 13.75 square meters for the area. If you have questions about this, please ask. This is exercise 3F. Question 9, I think 9 and onwards. So 9, 10, 11, 12, well up to sort of 18. But 9 to 18, have a go, a sample of those, and see how you do. Please ask, get in touch with me if you need. Thanks.